Well, let's kick the event off then properly, and welcome to Nottingham, and welcome to this special event that we've called Beyond the Code of Practice. So my name is Tim James, I'm Standards Director of PATTA. In a few moments I'm going to introduce Jim Wallace, who's our guest speaker. I'll probably let you introduce yourself, Jim, in a couple of minutes. So, a bit of a background about today's event. PATTA is about raising standards within the patent testing industry. It's about educating, it's about sharing good practice, etc. And the reason that we call the event today Beyond the Code of Practice is we see a lot of people, I'm sure you've seen these discussions that go on in Facebook sort of late at night, and people often get very passionate about a particular issue that's going on. Some of these discussions go on long into the night, and they can get quite aggressive at some point. And what we sometimes find is a lot of people come into the patent testing industry and they do maybe a couple of days training course, especially if they do a City and Guilds course. The only document that they'll sort of study in great detail would be the Code of Practice. And what we find is a lot of people probably don't have a deep understanding of where the Code of Practice comes from, the sort of the legislative framework that it's sort of built on. And we thought it'd be a good idea just to explain a little bit about what else is out there, not only just from the Health and Safety Executive, but from British standards as well. Jim and I were talking just before we started, and I think the reason that probably, or one of the reasons that we don't sort of talk about the British standard for recurrent testing, which came out in 2021, is that right? And the reason that we don't sort of talk about that very often is because the standard itself to buy is 270 quid. Whereas, you know, we moan about the fact that the Code of Practice is 60 quid, and we sort of buy that one, we argue about the content of that, but there's a whole load of other stuff out there. And so just sort of trying to put the Code of Practice into sort of context and explain sort of where patent testing fits in with all of that, we thought would be a really useful way to spend an afternoon. So Jim Wallace, I'm sure will be familiar to many of you. He's one of the directors of Seaward. He's behind many of the patent testing machines that you and I use on a day-to-day basis. What you might not be aware, he's also an expert in electrical safety standards. He's certainly the best person to come and talk to us today about this particular subject. He doesn't work at Seaward anymore. He's now an independent consultant, so we're very lucky to get him here today. The plan is we're going to probably talk until around about 4 o'clock, but we'll take a comfort break after about an hour or so. So more tea and coffee. You're welcome to join us in the bar afterwards. We'll have a bit of a Q&A session in around about an hour's time. Hopefully there'll be some questions that pop up from what Jim talked about. And then if you're going to join us in the meal later on, then we'll see you there. So hopefully by about 11 o'clock tonight we'll put the world to rights and we'll solve all the problems. But for now, let me hand over to Jim Wallace.
Thanks very much, Tim. So that's me, that's what I'm going to talk to you about. But beyond the Code of Practice and electrical product safety standards and regulations, if it's all right with Tim, if anyone's got any questions as I go through, I'm quite happy to answer them there and then. Or this is me going to tell you everything you wanted to know about standards and more. And I thought I'd give you a bit of background in terms of where they come from, how they're created, who writes them, who publishes them, etc. So this is my background. I moved to the Northeast in 1989. So I've been involved in electrical safety for about 33 years. I spent 7 years as a medical technologist at Newcastle General. My then wife said that I should get a proper job and go into industry. So I joined Seaward as a design engineer, became engineering manager, and then moved into sort of more commercial roles, product manager. So I met some of the people I can see around here, talking about product specs and what they should do, and what you wanted from products, and the fact that you haven't got any straps on the Apollo, you haven't got, that sort of trying to capture that sort of information. That's really what product managers do, talk to end users and specify what the product should be. I then became a director of Seaward until it was sold in 2015 to a German company called GMC. I then specialised in technical standards work up until December 2020, when my role was a victim of the COVID downturn, and parent company in Germany decided they wanted to save a few quid, so I was up the road. Gambika is a trade association, much like PATTA, and Seaward, Mega, Fluke, Martel, all of the instrument manufacturers are a member of that association. So I've been chair of their electrical installation test instrument group for, it's supposed to be a 2-year post, but I've done it for about 15 years now. Whilst at Seaward's whole product range and sort of product philosophy and business philosophy was based around standardisation. Seaward make products that help people comply with standards, so it was a critical aspect of the business. So at the request of the then owner, I started to get involved in actually producing standards themselves. So at the moment I'm a member of several Iec committees, I'll explain who they are, and a number of Bsi committees. I was involved as a contributor in the 2nd, 3rd and 4th editions of the IT Code of Practice, and then handed over to a colleague for the 5th edition. The Higher Association Europe, I wrote their Code of Practice in terms of the content about electrical safety and testing. So that's who I am. I'm sure all of you will be aware of some of these statements, but there's a big difference between regulations and standards. I think most of us know that regulations are law. Electricity work regulations or whichever one, they're mandatory. You have to comply with them because they're a legal requirement. If you don't comply, you've broken the law. End of. Standards, on the other hand, are completely voluntary. And I've had conversations with people where they've said it doesn't conform to BS 6181, and standards are voluntary. There's no legal requirement to conform to them. But what they do serve is they have this term is used in European law. It's called the presumption of conformity, and if you conform to a standard, there is a presumption that you comply with the regulation. So that's where they're very, very useful. And I'll cover a little bit of that in a moment in relation to back testing. But if you've ever seen a declaration of conformity, whether it's with your TV, washing machine, the PATTA test report, it's a CE declaration of conformity, and it says, we as the sole manufacturers declare this product conforms to, and they list European directives, and then they list standards. And the reason they list the standards is because the standards give this presumption of conformity with the regulations. So in terms of how do I know it meets the regulations? Well, because it conforms to the standards. And if I conform to the standard, legally I'm presumed to conform to the regulations. So that's where they're important. They're voluntary, but they give this presumption of conformity with legal requirements. A code of practice, lots of definitions in dictionaries and internets and whatever, but it serves as a generally accepted guidelines for people working in a particular profession. So there's one for in-service inspection and testing of electrical equipment. There's one for installers of electric vehicle charging points. There's all sorts of codes of practice, and they're usually written by industry. And they're guidelines, so they don't have the same clout as a standard. Because at the moment, we have the Iec Code of Practice, it's treated as gospel, it's the PAT testing Bible. There is now a standard which I'll walk you through. So in terms of the pecking order, Code of Practice is not the same as a standard. It comes about in a different way, and it doesn't have this ability to give a presumption of conformity. It's a key thing.
Jim, sorry. Yeah. So who decides what becomes, when a code of practice will become a standard?
I'm glad you asked that, Jim. Because we're going to cover it, yeah. I'm going to explain to you where standards come from and what makes a standard. So who can publish standards? Well, they have to be published by standards bodies. So internationally, so you've maybe heard of ISO. Anyone who's got a quality system is probably ISO 9000 registered. So International Standards Organization, they're a standards body, so they can publish standards. The IEC, which is the organisation that I'm involved with, that's International Electric Technical Committee. So the IEC publish technical standards. They don't do quality standards or what have you. It's purely electrotechnical. Then a level down, we've got regional standards. So within Europe, CEN is the European Committee for Standardisation. and a sort of subset of that is CENELEC. So electrotechnical standards in Europe, and what I'm going to talk about, that's published by CENELEC. And then we get down to national level. So in the UK, our national standards body is BSI. So standards published in the UK will be published by our national standards body. So the IET, for example, can't publish standards because they're not our national standards body. They can publish codes of practice, they can publish guidelines. You can publish, I can publish a code of practice, but I couldn't publish a standard because I'm not a recognised standards body. I'll explain the relationship between these as well. So the IEC, just to give you an idea, there are 60 member countries and 23 associates, and there's about 80 or so like developing countries who are linked to the IEC. They're not members or affiliate members, but they benefit from what the standards contain. It's broken down into 204 technical committees and subcommittees. Within that, which I'll show you in a second, there's 1,444 working groups. There's approximately 20,000 expert members. That's the term the IEC use. So when I stand up and say I'm a UK expert, that's not me saying I'm fab. We're known as expert members. You're on the committee because of your expertise. This is about 2 years old, but at that point they've published 7,537 standards. They had 1,652 active projects. Interesting one, because when I first got involved, I thought, how does it take 3 years to write? So surely someone can just sit down and spend a couple of evenings, and rattle this thing out. But when I explain the process behind creating a standard, maybe you'll understand what it takes. That's the average time, so some take a lot longer. I've been involved in trying to create a tested standard where we threw the towel in after about 9 years. So CENELEC, we've gone from international down to European level. So that's the European Committee for Electrotechnical Standardisation. It's a non-profit organisation based in Brussels. The 34 member countries. Now, it's different from the EU because when in the run-up to Brexit, everyone's going, yeah, CENELEC, European standards, we want bent bananas and what have you. But CENELEC is not part of the EU Commission. The European Commission have asked them to be the European Standards Organisation, but they're not owned by, governed by, or what have you, in terms of the European Commission. So it's a private organisation based in Brussels. So the UK is very, very much still active members of CENELEC. So myself and lots of other people at national level still involved in CENELEC, writing European standards because they're going to become British standards. Similarly, BSI, BSI is a private company. It's nothing to do with the government. It's not owned by, it's not administered by, it's not governed by the government. It's a private company. It was incorporated by Royal Charter in 1929, and they are our national standards body. So in the UK, British standards, BS, are only published by BSI because they're our national standards body. They do all sorts of things. Obviously, there's publication standards. They're involved in quality assurance systems, but their role as the national standards body, NSB, that's funded by the government, by Business Energy, and Industrial Strategy, BASE, and they publish about 3,000 standards a year. So this is how standards come about. So majority of them are written by the IEC. So they're written by IEC technical committees. So they start as an international document. For European standards, so when you look at the numbers, so the IEC ones will start with IEC, so it's an IEC standard. 61010 was my Bible for 24 years at Seaward. That's the safety standard for test and measurement equipment. So you buy a PATTA tester, a multimeter, an MFT, an RCD tester, a loop tester, all of those, your declaration should say list IEC 61010 or EN 61010. That's the safety standard for test and measurement equipment. So it's published by the IEC. CENELEC then adopt it as a European standard and put EN, European norm. in front of it instead of IEC, so it's published a European standard. And then the rules for CENELEC members is that they will publish European standards as national standards. Yeah. So when CENELEC published this, BSI have got typically 6 months to publish it as BSEN. So that's what we see. We've got on the BSI web shop. It's effectively the same standard. When it comes to European, we might include some like regional requirements, because the IEC, CE marking is a European thing, CE marking, that's European. So we might have to include information specifically for Europe in the EN version. And then similarly, in the UK, we might put what's called a national forward. We might put specific requirements for the UK, because our laws might be slightly different. But that's the rules of being a CENELEC member. You have to adopt European standards, and equally you have to withdraw any national ones that may conflict with that, so they'd be removed. So this is how the whole machine works, and how I'll explain how I get involved. So the IEC has these 204 technical committees. The technical committee, the scope, they have a scope in terms of what they're allowed to develop standards for. It can be quite broad. So if you imagine like TC85, it is measurement of electrical and electromagnetic quantities. So that's quite a big gambit. We can write standards for PATTA testers, installation testers, electricity meters, basically anything that can measure electricity or electrical quantities, that's within our scope. So it's broken down into working groups. There'll be a working group that specialises on the terminology used in the standards. There's one that specialises in the test and measurement equipment, like PAT testers. There's one that looks after installation monitoring equipment. So within the technical committee, there's multiple working groups. Where do the people in the working group come from? Well, at national level, so within BSI, for every IEC committee, we have a corresponding UK one called the Mirror Committee. So IEC TC85, IEC committee, so BSI they call it PEL 85. So that's the Mirror Committee so in other words, it covers the same subject matter. So to get on here, you have to be a member here. So you join a national committee, and then you say to BSI, I want to be a UK expert on the IEC working group. And they say, okay, they write to the IEC, we want to nominate Jim Wallace as our UK expert for TC85, so that you're up there. But how do you get on the BSI committee? Well, they've got very strict rules about who can and can't be on national committees because of vested interest, for example. So when I was at Seaward, sat on the committee, I wasn't allowed to be there on behalf of Seaward because common sense, write the standards so that only Seaward products meet it, tweak it a bit. You can do that in the code of practice, by the way, in the 3rd edition. Put RCD testing in there, develop a PAT tester with RCD. It wasn't coincidence that Seaward brought out a tester with RCD tests in there, and the code of practice included RCD testing. You say, well, why would your company pay for you to go to meetings all around the world? Well, because it gives you a heads up in terms of what's coming. So to be on a national committee, you have to represent an industry. There are exceptions where we've invited people, academics from universities who are experts in a particular field. So the one for grid-connected PV systems, we've got several people from Loughborough University. We've got a lady who's a professor at Newcastle University. So they're on the committee because they are real experts, much more so than some of us in the industry. So I mentioned Gambika at the start. So I'm the Gambika representative of the BSI committees. Equally, Tim could say to PATTA, I want to, write to BSI and say, I represent the PATTA Trade Association. I would like to be on this BSI committee representing the PAT testing industry. That will get you up to this level, and then you can say because most standards are written as IECs and filtered down. So if you want to be involved in actually having a say in the content, you have to work within the IEC, because BSI are just publishing what's already been published. So you want to be a mover and shaker, you need to get at the top of the tree. So that's how the system works. If you want to create a new standard, the National Committee write a proposal saying, we think there should be a new standard for battery-powered PAT testers, because there isn't one specifically for that, so there needs to be one. So they write a proposal, it goes to the IEC, you put some information like a rough outline of what you're going to have in the standard. The IEC send it to all the national committees, UK, Germany, Holland, France, Spain, Portugal, it goes out to all the national committees with a questionnaire saying, do you support this work? If so, have you got someone you want to be involved in it? What's their name? And all the committees vote on it, and if it gets approved, then the technical committees start working on it. Equally, if it doesn't get approved, it's gone. So that's how standards are born. It's generally industry saying we need a standard for a particular application or a particular product, and at national level, someone writes a proposal, goes to the IEC, goes out, gets voted on. And then, as the standard's developed, the working group they'll write a draft. Here's a rough outline of our standard for battery-powered PAT testers. They must measure earth insulation as a minimum. We'll put leakage in there as an extra. The battery life must be 3 days. So you write a draft, give it to the IEC. They send it out to all the national committees. They read the draft. Someone goes, 3 days, that's not good. I'm not happy with that. Change it to 5 days. So you get lots of comments back from national committees. Get together, review them all, go through them, respond to them saying, yeah, you're right, or bugger off, we're not changing that. So that's where the 3 years comes from. Every time there's a draft, IEC send it out to all national committees. They comment on it, they vote on it, comes back. But bearing in mind that the working groups typically meet twice a year, because we're all over the world. Zoom is great for the last couple of years because it's so easy to have meetings, and there were more meetings because MS Teams or Zoom, you just say anyone available in 4th of July to have a meeting. So the IEC and Senelec, they banned face-to-face meetings until this year. We had our first TC85 face-to-face meeting in Madrid in March, and I came back with 200 duty-free fags and COVID, so wasn't quite planning on that. I'd avoided it for 2 years. I went to a room about this size, 13 people, and 8 of us caught it. But so we meet twice a year, so it's quite a you might go out for comments and everyone goes, brilliant, best standard I've ever read, or it might come back with a whole raft of, and that's what we experienced with the PAT testing. I'll explain that how that came about, and we didn't realise just quite how many people would upset. This is the underpinning principle of standards is called consensus. And one of the reasons why the whole thing takes so long. So a standard, I think Lee was asking about, creating them. So a standard is a document established by consensus and approved by a recognised body. So it has to be published by a recognised body, but it has to be established by consensus. And consensus is different from majority. So even if most of the people around the table agree with the content, if someone strongly disagrees with it, that's not a consensus. So it won't happen then. So there's a lot of debate to get everyone on board. So and that's reflected in the voting process. So for something to receive a positive vote, at least 2/3 must vote in favour of it, but less than 25% must vote no. So quite often things get knocked back, not because there isn't sufficient support, but because too many people object to it. So it's that balance. So to have a consensus, there must be most are in favour and very few object to it. So that's quite a challenge. And the reason I want to explain this is because a code of practice is not a consensus document. it reflects the views of the organisation publishing, whether that's the IET or whoever. So I was involved in the second, third, and fourth. Tim was involved in fifth edition. You go to a meeting with an ever-growing committee of people who talk about what should be in the code of practice, put views forward, say why these tests are important, how they should be done. But at the end of the day, it's the IET's code of practice. So it's their decision what goes in, what comes out, what limits are in there. They have ownership of it. So it's very different from a consensus process. So no matter how much Tim or I are unhappy about something, that doesn't mean it won't be published. In case you want to spend your 270 quid, it's before I forget, there is an alternative to spending the 270 quid, because I work on a freelance basis. I need access to lots of standards. I have access to some as a committee member, but if they don't belong to the committees I'm on, I can't see them. BSI do offers for businesses, but Seaward was a £15 million business, but it was too expensive for them, where you can pay an annual subscription and that gives you online access to standards. But you're talking that it starts at about 10 grand, which is a lot of money to pay, and particularly with Seaward, we want access to all the standards for our products. We made production, or they made production line testers, so we needed, it's just a nightmare. But a lot of local libraries have an online reference section, so it's worth checking out. You join your local library. I live in Sunderland and they don't do this, but Durham do. So if you're a member of Durham Library, you can go to Durham Library website, put your ticket number in, put your surname in, online reference, British Standards Online. Click, takes you to the BSI website, type in the standard number. So you can't print them or download them because of copyright, but you can view them. So it may be, I give you the numbers, the new standards. It may be the case that just by joining your local library, you can go online. You don't have to pay the £270. You can't get a copy of it. You can read through it. You go, I just want to check out what it says about the leakage test. You can probably access it online. But if you're reading one, there's very specific language, and there are Iec directives. So all of us involved in writing standards are given directives by the Iec, and they tell us about the structure of the standard, the sections it must include, the fonts that are used, the alignment of the sections, they're all done to a set format. But with the language, if something is a requirement, i.e. you have to do it to conform to the standard, the word shall is used. If something says the tester should have a continuity measurement on it, that's a recommendation. If it says it shall have it, if it doesn't have it, it doesn't conform. So shall is a requirement, should's a recommendation, and it may do this is a permission. So you maybe never get into that, but it's caught a few people out with reading standards. So in terms of product safety tests, or product safety standards testing, products are generally tested at several stages. So when something's being developed, whether it's by Seaward or whoever, you're testing the design, yeah, and that's known as type testing. You're testing to see whether it conforms to type. That's where it comes from. On the end of production line, that's referred to as routine testing, and during the life of the product, we talk about UK in-service testing, but the new standards use the term recurrent because that's more widely used in Europe. So in-service and recurrent testing are the same thing. The other important one is after repair, and that's why the Hire Association, they've got their own code of practice because they're quite often repairing things after hire, so they want to do a different set of tests. Worth mentioning, whether you're doing type testing, routine testing, in service or after repair, there's fundamentally two things that you're checking. in standards, parts that can be touched by the user, and there are tests to determine whether you can touch it, believe it or not, there's a British standard test finger. So you buy, I first joined Seaward and found it in the engineering. What the hell is that? Sort of funny shaped bit of metal on a plastic handle. It's a British standard test finger, so it's a specified size. So basically, if you can put a standard test finger onto something that's accessible, if you can't reach it, it's not accessible. So it's the whole discussion about, I'm trying to do an earth continuity test and I don't know where to stick my probe. I can see a metal screw inside the middle of the fan, but I can't reach it. I said, well, why do you want to test it? It's not accessible. Because if you can't get a probe on it, then I can't touch it. So even if it's got direct mains on it, so what? You can't touch it, there's no safety hazard, is there? So the principle of standard, yeah, which parts are accessible, and the one thing we don't want accessible parts to be, the term used in standard is hazardous live. So it's more than a certain voltage and capable of delivering a certain current, because without current there's no hazard. Think of nylon carpets, electrostatic shock stings, but it's not dangerous. It might be 8,000 volts, but there's no current behind it. So it's the volts that jolts and the mils that kills. Yeah. So you need voltage and current. So the way we refer to that in standards, like a dangerous voltage and a dangerous current, that's called hazardous live. So it's hazardous. Yeah. So all of these tests are done to determine whether parts that are accessible are hazardous live, because that's not allowed. Yeah? You can have something that's dangerous and touchable. So that's the first thing we check. And then the second thing we want to know is, if there's a fault on the equipment, is it still safe? And usually, in the case of class 1 appliances, the thing that stops it becoming hazardous live is the earth wire. So under normal condition, we check it, all good. If there's an insulation fault, it's got an earth wire, so it's safe under normal condition, and it's safe when it's a fault. So it doesn't matter whether it's type testing, routine testing, in service, after repair. That's all you can check for. Are accessible parts hazardous live, and would they become live under a fault? So there's different ways of doing it, but the whole thing's based around that. So type testing done during development. Essentially what you're doing is checking that the product that you're examining meets the requirements of standard. As you might imagine, I think this is somewhat like Liam Neeson, but you need a very special set of skills to do that. I wouldn't expect, and I say this with great respect to people involved in service testing, but you need to really understand what the standards are about and how to do type testing to make that assessment. So if you buy something out of Argos, you would need to be pretty well qualified to assess whether it actually met the standard for washing machines. So that's not part of routine testing. Checking that products conform to standard. You're checking that they meet the requirements of the code of practice or the new recurrent test standard. You're not type testing like that. That's when you get into the sort of 20 years of experience to know how to do that. It's generally done in a lab. You need specialised test equipment, and it can be destructive. You might have, years ago we used to do a thing called flash testing of dielectric strength or high pot. Still do it in the higher industry. It generally involves about 1200 volts or up to 3000 volts for class 2 doubling set appliances. Do it with a probe. Fine doing that as a type test because in a controlled situation, one, it's safe. Two, I can tell whether it may have damaged the product. If you're doing that in a routine, what you don't want to do is test something and take a product that was completely safe and make it unsafe by damaging the insulation. So that's why we don't do type testing in service, because it can destroy the product. Routine testing, so quite a few standards actually have an annex that give you the requirements for production line or routine testing. It's fairly common for them to have a set of tests at the end to make sure that basically everything's assembled properly. When it's gone down a production line, Electrolux or whatever, someone hasn't, with a drill driver, put a screw through the live wire screw or trap the wire inside the enclosure. It's done in a production environment. It's based on type testing, but it is less severe because what you don't want to do is damage the product just before it's out the door. Testing after repair. There's no guidance in when I talk about product standards, I mean a product standard is the standard for projectors. There's a product standard for washing machines. There's a product standard for electric vehicle charging points. Each type of electrical product has a standard specifically for that product, for that group of products, and that's what defines the safety requirements for them. But they don't cover testing after repair, and it's generally done to look for assembly faults. You take it apart, you replace the motor in something, you put it back together, you put the cord grip through, and you catch the edge of the mains cord, and you've got the screw head there, which is touching the live wire. So that's why you do it. It's done in some sectors, as mentioned, the hire industry, but it's not commonly done during current testing. In service, this is your bread and butter. It's done in the environment where the product's used. It's based on a simplified version of type tests. Because one, they need to be quick. Two, they need to be safe for the person doing the tests. And three, they need to be easy to apply. It is the problem we face. If you look at the standard for IT equipment, for white goods, whatever, there's absolutely no guidance on recurring testing. So that's why the code of practice came about. There's nothing in any of those standards that tell us what to do on a routine basis. Historically, people would try and follow, certainly in the medical industry, they'd follow the IEC 60601, which is the safety standard for medical equipment. We used to use that for in-service testing. So we put 25 amps down the earth wire of absolutely everything and do lots of fairly arduous testing on medical devices. So to try and resolve this point, TC85 said, right, we're going to write a standard that just talks about recurrent testing of electric equipment in the workplace. Don't care what it is, but we're going to do that.